going to get the localized dyeing, whereas in case of the dyeing, we are going to have the uniform coloration of the textile material it is there. Now, whenever you are carrying out the dyeing or the printing it is there, see our requirement that whatever the color which is produced over there, it should withstand the various external agencies. Just like what we got, as I told that we got the rubbing, washing, light. Again, in the various chemical wise, if you see color fastness to acids, alkalis, bleaches. Again, in the bleaches, we got the various type of the water, the bleaches which are using it is there to that, even to the saline water, perspiration. So these are the various agencies are there to which our requirement that whatever the color which is produced, it is there, it must have good adherence or it must have the good resistance toward the all these agencies over there. So coloration should not be restricted only to the fiber surface, but it should penetrate the fiber cross section also. Now see, whenever you are carrying out the coloration, it is there. See, our requirement that whenever you are carrying out the dyeing, it is there. During this particular dyeing, whatever the color it is there, this color should not be only onto the surface. That is actually not required except denim. Denim is exceptional, it is there. Okay, yeah, back. I think there's some network issue it is there. That's why. So whenever you are talking regarding the coloration, it is as I told that it is not restricted only onto the surface it is there, but whatever the dye it is there, dye must penetrate inside the fiber structure it is there. If only onto the surface if it is there, what will happen? Whatever the dye it is there, this particular dye will get easily removed during the subsequent washing it is there. But that is not our requirement it is there. That our requirement that whenever you are carrying out the dyeing it is there, whatever the dyes are there, this particular dyes must remain on to the fabric or yarn or the fiber throughout its working life. It is or throughout its service. It is there. Now, whenever you are talking regarding the dye fiber interaction, it is there. See, one of the important criteria that you have to take into consideration that is nothing but the dye as a color compound that we have to take into consideration. It is there. Now, if you see the whatever the dyes and commonly we are using the term color, it is there. What the difference it is there? See in the dyes, we are going to get the two things. One that is a chromophore and the oxochrome it is there. Whenever these two things they are coming, it is together, then only the dyes form it is there. Now, whatever the dye which is there. So dye must be soluble in water and can be made soluble in water. Suppose if it is easily soluble in water, it is there, that is well and good. Just like direct dyes, reactive dyes, they are water soluble dyes. Whereas in case of VAT and other sulfur dye, these are the insoluble dyes are there. So what we are doing, we are making them soluble by means of the other process. Just like alkali reduction process it is there. Where whatever the VAT dye it is there, in a VAT dye we are adding the alkali NaOH and we are adding the reducing agent that is nothing but the sodium hydrosulfide, so that whatever the dye it is there, the insoluble form of the dye will get converted to the soluble form it is there. Now, whatever the dye it is there, dye must possesses affinity to the fiber to be dyed. Now, so it is not only the required thing that only whatever the dye it is there, we got the dye, we got the water soluble, or we made the water soluble dye it is there. But next thing that is required is nothing but it must penetrate. It must possess the affinity toward the fiber. Affinity means it must have the interaction towards the fiber. See, though suppose now the dye is there. Suppose these are the dye particles are there, and we got the fiber over here. Now dyes are not going on to the fiber. they are not having any position, or we can say the particularly the affinity toward this fiber. So here our requirement that whatever the dye it is, the dye must get affinity toward the fiber. Hmm? That is the next important thing which is required as per the dye's concern. Next, not only the affinity. Now, next thing what is required, whatever the dye it is, the dye must penetrate inside the yarn cross section or the fiber cross section under the dyeing condition. Now, we should not stop up to this particular point. Now, suppose here we got the fiber and the dyes got the affinity and they are deposited onto the surface. No, our requirement is not this much. What is our requirement? That whatever the dye it is, the dye must penetrate inside the structure also, fiber structure. Hmm? From the solution to fiber. That is again requirement it is there. Hmm? Means first thing whatever which is happening it is there, and that is a affinity, means there will be the deposition of the dye particles onto the surface, that is called that adsorption. Okay. Now whatever the second step it is there, that is called that penetration, which is happening during the our exhaustion step it is there, where more and more dye will go in a fiber cross section it is there. Now next important thing that only the dyes got penetrated, but they are not yet fixed. So what is our requirement? That interact with the fiber with a suitable dye fiber bond it is there. Now next thing, that is nothing but the fixation it is there. So whenever you are talking regarding the dye fiber interaction, or whenever you are carrying out the dyeing it is there. Say in dyeing you might be studying the mechanism of the dyeing, where the three steps are there. Initially adsorption, means whatever the dye it is there, the dye will get deposit onto the surface. Second, that is nothing but the penetration, which is happening during the exhaustion. And after the exhaustion is over, what we are doing? We are carrying out the fixation over there. That is called that our interaction of the with the fiber with a suitable dye fiber bond. Now, when you this particular term suitable dye fiber bond, it is there. Now, there are various type of the possibilities are there depending upon dye and the fiber. That part we are going to see over there. That various type of the bond formation, just like we got the van der Waals process, hydrogen bonding, salt linkages is there, covalent bond formation. All these particular various type of the bonds are involved whenever you are talking regarding the dyeing of the fiber. It is there. So whatever the interactive process depends on to the nature of the fiber and the nature of the dye which you are going to use it. And this particular thing, the nature of the dye fiber interaction only determine the fastness property of the dye to the external agencies. There are some exceptional to this rule, just like I told you the denim it is there. Means whenever you are talking regarding the color fastness to various agencies, which are the point that we have to take into consideration. First, that is nothing but our completely dyeing mechanism, in which our requirement that whatever the dye and the fiber it is there, it must have the affinity. There must be adsorption of the dye onto the fiber. Second thing, that is a penetration of the dye inside the cross section of the fiber under the suitable dyeing condition that is required. And third thing, that is nothing but the interaction with the fiber, that is nothing but the during the fixation stage, whatever the dye fiber, actually there is one term it is there, that is a interaction of the fiber with the suitable dye fiber bond it is there. Now whatever this particularly bond or suitable dye fiber interaction forces are there, that we have to take into consideration. Now whenever this particularly the interaction forces are there, these interaction forces are depends on nature of the dye and the fiber, and that is called the dye fiber interaction it is there. Now as I told that whenever you are talking regarding the dyeing it is there, there are three steps of the dye system in the three phases which is happening. First, initially we are going to get dye in a solution. Second, we are going to get the dye onto the surface of the fiber. And next, that is happening into the interior of the fiber. So just now whatever I told you, that dye we got initially in a solution. Then second, deposition onto the surface. Next, that is a penetration. And after the penetration is over, fixation it is there. Means whatever the dye which is at the interior of the fiber it is there, it must remain as it is. That's the requirement it is there. Okay. So these are the steps. Means initially we are going to get the in dyeing three types of the equilibrium exist. That is a dye in a solution, dye in a fiber, dye in the interior of the fiber it is there. So first equilibrium transfer of the dye from the solution to the fiber surface it is there. Second equilibrium penetration of the dye from the fiber surface to the fiber interior, disturbing into the first equilibrium process continue till three phases are equilibrium it is there. So it is again, as I told that in a solution, then in a onto the surface, adsorption, inside the surface, penetration, and lastly that is a fixation. So these are the steps which are required over there. Now, whatever the last step it is there, as I told that hmm, regarding this point, that the must have the interact with suitable difiber bond. So whatever these various interactive forces are there. See, these are the various interactive forces which are acting between dye and the fiber it is there. So first, that is a van der Waals forces, which is the weakest force it is there. Second, we got the hydrogen bonding. Third, we got the electrostatic attraction. And fourth, that is nothing but the covalent. Yeah, I think network is bad. I just check. Yeah, it's there. Okay, so whatever this particularly various type of the forces are there which are acting between the dye and the fiber it is there. So these are the four different forces are there. Van der Waals forces, hydrogen bonding, and the electrostatic attraction and covalent bond. So when this particularly the bonds are formed and which type of the dyes and the fiber these bonds are present, that we'll see. Now, when you are talking regarding the cellulosic fibers, and in cellulosic fiber, we are going to the various type of the dyes, just like direct dyes, wet dyes, reactive dyes, sulfur dyes, solubilized wet, all these various type of the dyes we are using it is there. Now, if you see in this case, see in case of the direct dye, wet dye, sulfur dye, solubilized wet, we are going to get the two types of the bond. One that is called the van der Waals process and the hydrogen bonding it is there. Hmm. Though see individual bond, if you see, they are weak, but when they are coming together, they are giving the good strength it is there. Whereas in case of the reactive, see the name is self indicate that what the reactive dye it is there. This reactive dyes forms a covalent bond with the fiber it is there. And if you see the hierarchy wise, that is a van der Waals process, hydrogen bonding, electrostatic or the ionic bond formation, and the covalent bond it is there. Covalent bond is the strongest bond it is there, where the bond energy is around 30 calorie it is there, kilocalorie. Whereas hydrogen, this van der Waal, we got the 1, hydrogen we got the 3, then ionic we got the 7, and in case of the this covalent we got the 30 it is there bond. So these are the various bond energies, are there bonds which are forming along with the fiber it is there. And whatever the name is said, as I told you, in case of the reactive dye, indicate that the reactive means these dyes are chemically reacting with the substrate. That's why they are forming a strong bond. It is there. Clear the point? Okay. The next case with the wool, silk, nylon. It is there. Now, in case of the wool, silk, nylon, we can use the various type of the dyes, just like we can use the direct dyes, basic dyes, acid dyes, metal complex, reactive. All these dyes we can use it for the dyeing of this particular all three fibers. Now, if you see that all these three fibers over there, in all the this fiber, there are two different type of the end products, end groups we are going to get it, not the products. Means we are going to get the carboxyl group, COO minus, and NH3 plus. We are going to get it. Means for example, when you are denoting the wool fiber, we are going to get the COOH. We are going to get, and here we are going to get the NH2. So when it get ionized, we are going to get the NH3 plus will be there, and COO minus will get it. So whatever the COO minus it is there, to this, whatever our basic dye will get duo, and whatever the NH3 plus it is there, to this our acid dye will go over there. Now whatever the bond which is formed over here, see there are ions are there, NH3 plus, COO minus it is there. To this, whatever the bond which is formed, that is called an ionic or the electrostatic force. So whatever the bond formation it is there, that is because of the electrostatic attraction it is there. Okay. Next, that is a for the polyester, we are using the disperse. As if you see, whatever the disperse it is there, they are not reacting with the substrate. They are not having affinity. So dyeing mechanism of the polyester is completely different. So whatever the dyeing of the polyester it is, see dyeing of the polyester we are carrying out at a temperature above 130 degrees Celsius. At about 130 degrees Celsius means above 80 degrees Celsius, because TG of the fiber is 80 degrees Celsius. So as you are going to increase the temperature above 80 and up to 130, it is observed that at 130 there is a white form in this case. And at 130, we are going to get a maximum whites over there. Whites means gaps are formed over there. Through these gaps, whatever the dye penetration it is there. And later on, when you are carrying out the cooling it is there, whatever these gaps which are formed it is there, it will get closed and the dye particles get entrapped over there. So during this particular phenomena, whatever the bond which is forming over there between the dye and the fiber, that is a van der Waal forces and the hydrogen bonding it is there. Next, related to the acrylic, we are going to use the cationic dye, or that is nothing but the basic dyes we are using it is there. And there is also formation of the our ionic bond it is there, of the electrostatic. So these are the various type of the dye fiber interaction or the bonds are formed over there. Clear this particular point? Any doubt regarding up to this point? Yes, any one of you? I think after lunch you got a very good sleep. Am I audible?
Yes, sir.
At least
Yes,
okay.
sir.
Okay, got it, got it. So I ask one question, whether have you understood this particular point or not? Or you have not heard of? Okay, so from next lecture again, I will stop the recording. So that will be better. Okay, then next, how this particularly the various forces of the attraction and the washing fastness is related over there. So dyed fiber must meet the certain fastness requirement to the various agencies like washing, light, rubbing, or various chemicals which I told you earlier. So wash fastness depends on to the force of attraction between the dye and the fiber. Second, that is the physical state of the dye inside the fiber structure, means how this particularly the dye is situated inside the fiber structure, whether there is a strong interaction or whether there is a weak interaction it is there, that then physical structure of the fiber, how is the fiber it is there. Now see, in few cases, suppose the same dye we are using, in few cases we are going to get a good color fastness, in few cases we may get the poor color fastness, because we must know again the physical structure of the fiber, how the structure of the fabric is there, that will also affect the fastness. Means here we have to take into consideration this point, that is nothing but the force of attraction between the dye and the fiber, physical state of the dye inside the fiber, and physical structure of the fiber. So all these parameters we have to take into consideration. Now, whenever you are talking regarding the forces of the attraction between the dye and the fiber, as I told you that we have to take into consideration this particular criteria. That whenever you are considering the bond energy, covalent bond got the highest bond energy, electrostatic second, hydrogen third, and van der Waals force 1, 3, 7, 30. Likewise, the bond energy it is there. And when you are talking regarding the wash fastness over there, so in that case, we are going to get the excellent wash fastness with the reactive dyes, followed by acid, metal complex, and the cationic. Then later on, we are going to get direct, wet, sulfur, and the dispersed dyes. Now, see, whenever you are talking regarding the washing fastness, it is there. See, it is not only the this dyes hierarchy is important, but also the important that how we are carrying out the dyeing also. Though we are using the term that reactive dyes are forming the covalent bond and we are going to get the excellent color fastness to washing. No. Suppose if you are not carrying out the proper reactive dyeing, say after the dyeing is over, our requirement that we need to carry out the proper soaping operation. If you are not carrying out this soaping operation properly, what will happen? Whatever the hydrolyzed dye is there, it will get deposit onto the surface of the fabric, and later on during the washing, this particularly the dye will come out. Now what does it indicate? Reactive dye is giving us the poor color percentage. No. So here we have to take into consideration whatever the dyeing methodology which you are following it is there, that is also plays a role over here whenever you are talking regarding the color fastness to washing over there. Hmm. I told you related to the exception where wet dyes onto the cotton it is there. Hmm. So whatever the dye inside the fiber or the water is an insoluble form it is there. And state of the dye inside the fiber is aggregated. That is because of the high molecular weight it is there. So both these factors lead to the very high fastness on cotton through weak forces of the dye fiber interaction. As I told you that there are a few exceptions, just like indigo I told you, but that is again uh, a wet dye only it is there. Now wet dyes on the cotton. Why wet dyes? Though this is our criteria, it is there, or the hierarchy is there that wet dyes and the dispersed dyes may give us the poor color fastness, but exceptions are there that wet dyes onto the cotton and the dispersed dyes onto the polyester it is there. Now why these wet dyes and the dispersed dyes causes us a gives us the excellent fastness, though they are forming a poor bonding over there. So first case, whatever the dye it is there. See dye inside the fiber, hmm, water insoluble form it is there, and the state of the dye inside the fiber is aggregated it is there, because of the high molecular weight, so that when you are going to washing it is there, during this particular washing, whatever the dye it is there, the dye is not coming out easily. Again, when see we are carrying out the fixation of the dye onto the fiber it is there, initially wet dye they are insoluble in water, we are during the dyeing we are making them soluble in the water. Later on, when you are carrying out the fixation it is there, again we are making that particular dye insoluble. So whenever this dye is becoming insoluble, it is there. Hmm? So such type of the dye is difficult to come out during the washing it is there. That's why wet dyes gives us the excellent color fastness to washing it is there. Similar case with the disper dye. See dye inside the sorry.
हे बघा बघा माझं लेक्चर चालू आहे सर बडबडत आहेत टाकू हे बघा
Okay, hello.
हा माझं
Hello, someone mic is on.
अरे नंतर नंतर कोणाला लावायचंय नंतर लावा
Just someone's mic is on, it is there. We are getting disturbance in the lecture. We are getting disturbance in lecture. Someone's mic is on. Or someone make mute. Whose mic is on? Prapti. Okay. Huh. Okay, now see, in case of the disper dye, if you see what the dye inside the fiber, that is a water insoluble, it is there. And next, as we know that whatever the disper dyes are there, they are not having any affinity, as well as the dyes are insoluble in water. And we are going to get a good dispersion of the dye. We are going to get it over there. Second, that is a very compact physical structure of the fiber. If you see the fiber is a very compact polymeric structure, it is there. Because whatever the dyeing it is there, as I told you that during this dyeing, there are voids are formed or there are polymeric chains get apart from each other and the dye is penetrating inside this. And later on when you are carrying out the cooling, whatever the voids are there, these voids get closed and we are going to get the dyeing it is there. So that's the thing related to the compact structure it is there. And second, dye is unable to diffuse out under the washing conditions. So because of this particular matter, as the dye get entrapped over there, so whenever you are carrying out the washing it is there, during this particular washing, the dye is not coming out. That's why disper dye is also giving us the excellent color fastness to washing it is there. Now, whenever you are, okay, after the grayscale, I will show you the video related to the color fastness to washing. Now, whenever you are talking regarding the grayscales, it is there. See, we already used these two things that grayscale, there are two are there. One that is a change in color and second staining onto the adjacent fabric. Of the stain scales, we got it over there. So both scale measure the color fastness of the textile dyes. It is there. Now both scales are based on to relatively small difference between the product standards and the lot samples of any color in comparison of these two grayscales. Now these are the two grayscales which are used. One that is nothing but the change in the color it is there, and second that is a staining onto the adjacent fabric it is there. Now, if you see this change in color, so there are in both the cases we are going to get the 9 chips over here. You can check over here. We got the total 9 chips. Oh yeah. Now, when you are talking regarding the grayscale for color change, so this indicates the amount of fading of the color alteration with the washing or any other agencies of the specimen it is there. So here we got total 9 chips over here. Now in the 9 chips, if you see 5, there is no not at all difference. 4 to 5, little bit difference. Now if you see over here, this part, over here, this part is same. What is changing? Half part. Here, half. This slowly it is getting faded. That's why we are going to get a contrast over here. Now, what does it indicate over here? So this is our standard which you are using it is there, and this is our test specimen. So we have to compare how much is the tonal difference between the our standard and the test specimen it is there. Higher is the difference, poor is the fastness property. So here what does it indicate? 1 means poor, 5 means excellent it is there. Similar case with the grayscale for the staining it is there. So it indicates the amount of the staining of adjacent material that occurs with the washing or any other agency it is there. Now if you see over here, this particular, if you are in, this is a 5, this is a 4 to 5. See, this is not 4.5, 3.5. Huh? This is a 5, 4 to 5, 4, 3 to 4, 3. Then again 3 repeating 1. Then 2 to 3, 2, 1 to 2, 1. Likewise, it is there. Now, if you see over here, whatever the upper portion it is there, that upper portion is same. And here, whatever this portion it is there, that is the same it is there. Now, why we are going to get a contrast over here? Because whatever the color it is there, the color get transferred onto the adjacent fabric it is there. And there we are checking whatever the white adjacent fabric it is there, how much staining we got it over there. Now here also, whatever the 5 it is there, the 5 is excellent, mean not at all color transfer onto the white fabric. And second, that is 1 means poor means majority of the color get transferred onto the white fabric it is there. So we have to check the difference between white fabric and the our stained fabric it is there. And accordingly, we have to give the rating it is there. Clear? So grayscale for the change in the color it is there. So loss of the color using the grayscale change is evaluated by comparison to 5 pairs of the gray standards similar to those shown over here. One half of each standard. See here, though it is written point it is there, it is not point, it is a 4 to 5, it is a 3 to 4, though it is 2.5, it is a 2 to 3, 1.5 means 1 to 2. Always you have to give rating like this, not 1.5, 2.5, 3.5, 4.5. So one half of each standard is always identical chroma to the starting specimen, as I told you over here. And second half range from the starting chroma, no color loss to the white. That is a loss of the color it is there. And amount of the contrast between the treated and untreated fabric is related to the one of the standard pairs to yield the grayscale rating. So on the scale, 5 indicate that next to no color was changed, lost, and 1 indicate that most of the color is lost over here. Second, grayscale for the staining it is there. So the transfer of the color from the test specimen to the adjacent specimen is evaluated in a manner very similar to that of the grayscale in a change it is there. Again over here we got the 5 standard paste which are using. And one half of each standard is white and the second half ranges from no staining to the gray with a chroma value to the test specimen, great deal of the staining it is there. Again, similarly over here, see we got the value 1 which corresponding to virtually no staining and 1 indicate that the poor color fastness, that's almost color got transfer over here. So these are the color fastness grayscales are there. Now coming toward the point, that is a color fastness it is there. Now I told you the definition of the color fastness. So by color fastness, it means the resistance of the color of textile to the different agency to which these materials may be exposed during the manufacturing or their subsequent use. That is nothing but our color fastness. The color fastness is how fast is color, means resistance. So here color fastness is good, means whatever the resistance of the color of the textile is good, it is there. It did not change as well, it did not get transferred, it is there. Now, whatever the various agencies are there, see that might be various agencies are coming across during the manufacturing stage or during the subsequent usage it is there. For example, during the manufacturing, see suppose as I told that one case that is a top dyed goods are there. Now, when this top dyed goods were carrying out the processing it is there, they are coming in contact with the various type of the acids, alkalis, oxidizing agents, reducing agents, they are coming in contact. And we must know that what are the dyes which are used for such type of the yarn, they must have the good color fastness to these agencies. So that is during the manufacturing stage. And during the subsequent usages, that will be the rubbing, washing, perspiration. These are the few examples are there. To this, I would recommend that it must have the good, excellent color fastness. It is there. So it may occur due to the poor binding of the dye to the fiber it is there. Now when we can say the color fastness is poor, that one of the case that may be due to the poor binding of the dye to the fiber. Means if you got the poor dye fiber interaction it is there, then we are going to get this particularly the poor color fastness to washing it is there. Or the any other agency. Degradation of the dye. In few cases, whatever the dye it is there, dye will get degraded. That might be a hydrolysis or in another thing. If it is happening, it is there. That type of the dyes might give us the poor color fastness. Next, sometimes hue shift occurs, which completely changing the sample, and that we have experienced with the color fastness to alkali, where the completely change into the color of the sample was there. Even in few cases, you observe for the acid also. Hmm? So here, what is happening? Sometimes hue shift occurs. It is there. So next, that is nothing but the color fastness to washing. It is there. So whatever this method of the color fastness to washing it is there, it is designated or the design to determine the effect of the washing only onto the color fastness of the textile it is there. It is not intended to reflect the result of the comprehensive laundering procedure it is there. Means if you see whatever the color of the fabric before washing and after washing, these are huge change it is there. Hmm. Now whatever this particularly the color fastness to washing it is there. So wash fastness is nothing but the resistance of the color of the textile to domestic and the commercial laundering procedure toward the loss of the color and the staining it is there. So in this case, when you are talking regarding the color fastness, it is there to washing it is. Okay, I think one slide is missing. Okay, I have shifted it. It is there. Hmm. Just wait, I will check it where it is. Actually, I want to show you one more slide. If it is there, that I will show you. Mhm. Okay, actually, I didn't get that slide. I'll check it. If I get it, I'll. So to check the color fastness to washing it is there. Now, actually, I want to tell you regarding the ISO, that particular slide I was searching. If I get it, I will show you. Might be next practical, I will show you. So there are various methods are there, just like AATCC it is there and ISO. So AATCC test method number 36, that also we can use it to check the color fastness to washing. That is nothing but the characterization of the textile colorant, that we can use it. Or we can follow this ISO 105 C01 to C06 it is there. Now, whenever you are talking regarding the this test standards, it is there. Now, there are few standards are there that we have to follow whenever you are carrying out the color fastness. It is there. Whenever you are performing any testing, it is there. We have to follow the standard test methods over there. So just like in a physical, we got the ISO also it is there. BIS also it is there. ASTM is also there. Hmm. Likewise, in case of the chemical color fastness, we got this AATCCT there, American Association of Textile Chemists and Colorists, even ISO, BIS, all these test methods are also there. See, along with that, see, if there are few manufacturers are there, they got their own standard. Just like Mark and Spencer, they got their own standard, it is there. Even in German, they got their own, that is a DIN standard, it is there. So according to the country wise also, these particular standards are there. So whenever you are carrying out the color fastness to any of the agency, see one point that we have to take into consideration, that we have to take into consideration which test method we have to follow. Or if any buyer's requirement that specifically how to use this particular test method, then you have to use that test method also specifically. If they are intending to do the AATCC, then we have to do the AATCC. If IOC is there, we have to follow the ISO. Any of this we can follow, it is there. So what is the scope for this particular test, it is there. So the test is conducted to also quantify staining that takes place onto the adjacent fabric. As a typical home or the commercial laundering, the washing load will consist of all type of the fabrics. A fabric with a poor wash fastness extensively stained to other fabrics in a wash environment, it is there. That is a scope, it is there. So this test, why we are doing, we are checking to the change in a color also, and second for the staining onto the adjacent fabric. Hmm. Suppose when you are going to washing it there, along with the wash load, there are other type of the fabric also will be there, or the other garments also will be there. So our aim is that whatever the color it is there, that particular color should not get transferred to the adjacent fabric or the whatever the other washing load it is there. That is our aim, it is there. Now, when you're talking regarding the color fastness to washing, it is there. See, these are the few requirements that we have to use it. One that is required is nothing but the laundering machine, it is there, or the laundrometer. Second, we need to have this standard reference detergents, that we have to use it over there. Now, when you are talking regarding the standard reference detergent, it is there. Mean the requirement from the detergent is that whatever the detergent it is there should not be any phosphate. Whatever the detergent which you are going to use it is there, it must be free from optical brightening agent as well as the fluorescent brightening agent. Such type of the agents should not be there whenever you are using the detergents for this. So just like a standard suppliers are there, we got likewise ATCC also it is there, SDC, that is nothing but the Society of the Dyes and Colours, they are also supplying this standard detergents. Okay, related to the laundrometer or the washing machine, again there is a criteria that whatever the laundry machine it is there. See, in that we got the various variables. We can have the single container, we can have the 4 pot, 8 pot, 16 pot. It will vary the depending upon the manufacturer. But whatever the container size it is there, that is fixed. That is a 550 ml. Whatever the speed of the machine it is there, that is a fixed. That is nothing but a 40 RPM it is there. Because these are the standards are there. So wherever you are performing this particular test it is there should not be any change into the procedure it is there. That's why these are the criteria that you have to follow over there. Next, stainless steel balls are required. It is there that not we are not used, but if you are going to use the ISO 105 C045 test, in that these are required. Then multi-fiber adjacent fabric. Okay. Now regarding this multi-fiber adjacent fabric, see we can use the single fiber adjacent fabric just like what we are used during our practical, cotton wool likewise. Even see we can have the one multiple fiber fabric over there where see one strip of the fiber only we have to attach, means for example 10 by 4 centimeter of our sample and 10 by 4 centimeter of this multi-fiber fabric strip, that only we have to use it. Now in this case multi-fiber fabric MMF 10, if you see which are the fibers are there, we got the acetate over here, we got the bleach cotton, we got the polyamide, we got the spun polyester, we got the spun acrylic, we got the worsted wool. And here we got the AATCC MMF is nothing but multi-fiber fabric one filling strip, where we got the acetate, cotton, polyamide, Instead of polyester, now we got the silk over here. Instead of acrylic, we got this viscose over here. So here polyester and acrylic we are replaced with the silk and the viscose it is there. So instead of using the two multi-fiber fabric, instead of using the two adjacent fabric, only one fiber is sufficient over here. And you have to check whenever you are carrying out the state testing over here that's staining onto the adjacent fabric that on which fiber this particularly the dye got stained over there. Then next required that is a single fiber adjacent fabric which you have used for our practical that is nothing but the 5 centimeter by 5 centimeter bleach cotton fabric that we have to use. Grayscales that is staining, changing the color and the staining. These are required and color matching cabinet with a D65 lamp with a minimum 600 lux or more. So this is our color cabinet. It is there. That color matching cabinet that is also required for the final evaluation. It is there. Now, how to start with the experiment? It is there. A laundry machine is capable of rotating with a closed container in a temperature control bath at a speed of 40 plus minus 2 RPM. That is allowable limit. And machine is required to have the heating capacity with a good temperature control and the programmable countdown timer. Suppose if you are setting the temperature 60, again plus minus 2 degrees Celsius, that is allowable limit it is there. Whatever the precise time it is there, it must be there at a precise time it is there. Now see, whenever you are starting the experiment, it is there. See, our requirement that it must be a preheated storage module to be integrated in a laundering device. So what is our requirement? For example, ISO 105C03, 60 degrees Celsius, 30 minutes. Means at that temperature, 30 minutes it is there. Not the total duration. Means what we are doing, we are removing the bath after the 30 minutes are over at a 60 degrees Celsius. But whenever we are setting the bath, it is there, it is required to be preheat set. Suppose if our bath initially stage is at a room temperature and room temperature to 60, again 30 minutes, 30 degrees Celsius difference is there. And if our this controller where we are setting the program over there that temperature rising rate, if you are setting 2 degrees Celsius per minute or the 1 degree Celsius per minute. So that additional time is required, will be there. And this will give us a faulty reading. That's why here our requirement that we must use the preheated storage module. Now, what are the containers? As I told you that two sizes are there. One big container whose capacity is a 1200 ml. And second, that is a 550 ml plus minus 50 ml it is there. So as I told that use of the standard detergent is recommended. Why? Because the detergent do not contain optical brightening agent, which could interfere the evaluation of the color change. So two types of the detergents are available over there. That AETCC 1993 standard reference detergent, WOB without optical brightening agent, which is meant for USA and the Canada test method, and ECE reference detergent with phosphate and fluorescent brightening agent free for use in ISO 105C0 test. Next, standard soap, which you are going to use it for all these tests, it must be free from fluorescent brightening agent. It is there. So these are the specifications as far as the detergent is concerned. Next, how to perform this particular test, it is there. So every one of you have performed this particular test. Now, for test method ISO 105 C01 to C05 for this test, it is there. So prepare a specimen of size 4 by 10 centimeter of the textile sample in contact of the face side with the multi-fiber adjacent fabric. We can have the 4 by 10 centimeter sewed along the shorter side, that is nothing but the 4 centimeter, or else what we can do, we can have the two adjacent fabric like this of the same size. Suppose if our specimen is a cotton it is there, then we can take the cotton and the wool. If our specimen is a wool, then we can take the wool and the cotton. If the silk and cotton, likewise, we have to take it. Suppose when we are going to take the, as I told that one specimen may be of the same type of the fiber that. Suppose if the blend it is there, hmm, blend it is there. So in case of the blend, we have to take the whatever the higher percentage. Suppose now we got the blend of the polyester and the cotton it is there. So what we'll do, first adjacent fabric will be the polyester, second will be the cotton will be the, or polyester wool it is, viscose it is there. Again, you have to take the polyester and the cotton only. Hmm. So this is case with the fabric. Now suppose if you got the yarn sample over there. So what you have to do, in case of the yarn specimen, place the yarn mass equal to the half of the mass of the adjacent fabric used. Now see, we have used the two samples, 10 centimeter by 4 centimeter to adjacent fabrics, 1 and 2. Suppose both the weight is a 2 gram, both adjacent fabric weight is a 2 gram, then whatever the sample which you are going to take, that you have to take 1 gram. Hmm? And in case of the our, suppose now this is our 10 by 4 centimeter cotton, whatever the our specimen half it is there, that we have to put it over here, yarn sample. Hmm? And on this, we have to put the wool. Hmm? Now, in case of the fabric, what we have done, we have stitched only one side, but here we have to stitch on the four sides. Hmm? So that is case with the yarn, whereas in fabric, we are going to stitch only one side it is there. Hmm? And after this, whatever the sample it is there, that we have to put it in a container and do it necessary amount of the soap solution. We have to add it by keeping MLR 50:1 it is there. Liquor to material ratio. Now, whatever the things are there, so how we are going to take? Here we are going to take soap. If you see, this is ISO 105, C01, 2, 3, 4, 5, 6. 6, I told you, it is exceptional, which we are using mostly for the industrial purpose. So soap, in all the cases, we got the 5 gram per liter, 3, 4, 5. In this case, we got the soda ash 2 gram per liter. Temperature 40, 50, 60, 95, 95. Number of steel balls, in first three we are not using the steel balls, but fourth and fifth we are going to the steel balls. Time 30 minutes, 45 minutes, 30, 30 and 240 minutes it is there. Now if you see, as we are moving from test number 1, 2, 3, 4, 5, slowly whatever the severity of the test it is there, it is gone increasing it is there. Now in case of the 6, test method number 6, what we have to do? We have to take the soap 4 gram per liter. We have to take the sodium perborate over here. We have to add at the temperature 60 degrees Celsius. We have to perform for the 30 minutes it is there. So again, we got the further test 6, 7, 8, but these are the most commonly used test method it is there. And out of this is a commonly used because this is a moderate test method it is there. 1 is a lighter side, 5 is the heavier side, and we are mostly prepared to the moderate test method it is there. So after the this particular process is over, we have to remove the specimen, rinse it in a running cold tap water, squeeze it and dry the composite specimen in a air at temperature not exceeding 60 degrees Celsius with the 3 piece in contact only along the remaining line of the stitching. Means whenever you are carrying out the drawing, it is there, only this part is stitch. This is first adjacent fabric, second adjacent fabric, and this is our test specimen it is there, that only this part will be in contact and these three must be separate from each other while carrying out the drawing over there. Now after the drawing is over, you are let the change in the color and the degree of the staining with the help of the grayscale and the CCM, and we have to assign the ratings over there. Now see, whenever you are performing this particular test meter, don't take only one sample. Take 3 to 5 samples so that you will get the accurate readings over there. Hmm. So that care also we have to take whenever you are performing the color fastness to washing it is there. Clear regarding this test? Yes, any query? Okay, now I will show you how to perform the one video related to the color fastness to washing it is there. Mhm. Mhm. Okay. Can you see the video? Just any one of you? Yes. Tell me, any one of you, can you see the video?
No, sir.
No.
No, sir.
Okay, I got it. Now,
Yes, sir.
okay. Now just have a look on this video.
Hi friends, the color fastness against the washing test examines the color fastness of all kinds of textile materials after the washing procedure. The test apparatus and materials that we use in this test are the color fasteners test device, stainless steel containers with 550 millimeter capacity, stainless steel balls with 6 millimeters in diameter, multi-fiber adjacent fabric, ECE reference detergent that contains no optical material, non-dyeable fabric, third-class water, a magnetic heater, a precision balance, a gray scale, and a color comparison. To prepare the test sample for the test, it is marked with a template of 40 millimeters by 100 millimeters, 15 millimeters away from the selvages if the sample is fabric. The multi-fiber adjacent fabric is prepared at 40 millimeters by 100 millimeters in size. The test sample and the prepared multi-fiber adjacent fabric are sewn face to face along the short edges.
So in this case, what they have done, they have used multi-fiber fabric instead of using the two fabric samples, adjacent fabric, which we have used for our practical. That is actually the ISO
The
test.
fabric specimen is prepared in this way. If the test sample is made of yarn, the 40 millimeters by 100 millimeter yarn is put between the multi-fiber adjacent fabric and the undyeable fabric, and they are sewn along 4 edges. The sewn test samples are ready for the test. One liter of pure water and 4 grams of detergent are weighed to be used in the detergent solution that will be used for the test of color fastness against washing.
Now see, she is telling regarding the ATC test method. That's why there is a 4 gram per liter. It is there. There is a little bit difference between the ATCC and the ISO, but the procedure is almost same. It is there.
Hourglass is used for the weighing process, and then we reset the precision balance. The detergent is ECE reference detergent containing Then 1 liter of pure water is measured with the graduated cylinder and poured over the detergent.
So this we have given you the ready-made.
The detergent is dissolved in this way. After dissolving the detergent, we measure the temperature of the solution. When we see that it has reached 40 degrees centigrade, we begin to do the test.
That is a preheated water.
The prepared washing solution is at 40 degrees centigrade. The test sample is put into steel containers. 10 pieces of steel balls are put into the container. The amount required for the test solution is measured at 150 milliliters with a graduated cylinder, and then it is poured into the container. The lid is closed and it is placed in a preheated device at 40 degrees centigrade. By pressing the Start button, the test is started. This time, the sample is subjected to the test for 30 minutes in the device. The washing fastness sample is removed from the container. Then, the excess water is discharged. It is put in the beaker to wash off. Pure water, heated to 40 degrees centigrade, is used to wash off the sample with 100 milliliters of pure water at 1-minute intervals. To evaluate the color fastness against the washing test, the original sample is put on the left side.
Okay, then we have to dry the sample, and after dry.
To evaluate the color fastness against the washing test, the original sample is put on the left side, and the tested sample is put on the right side. The staining is evaluated with the gray scale. The gray scale, which has levels from 1 to 5, is placed on the tested sample and the appropriate level is found. Then, the test sample is evaluated. The tested sample and original sample are put side by side and the fading scale is used. The scale is rated from 1 to 5. The evaluation of the sample is finished by finding the appropriate value.
Okay. So that's it related to the today's practical. Okay. Any query regarding today's practical? Yes,
No,
any one of you?
sir.
Uh,
No, sir.
okay. So if there is no any query there, today we'll stop here. Next lecture we will continue with the